right, this is lab 5, combinations of resistors and a thermistor. So I'll be doing two sets of combinations of resistors. And what I'll do is I'll go to the first set, and what I'll do is, as we explained in chapter 19, what you want to do for this circuit, the first one is we will measure, set up the circuit and calculate the overall resistance of the 4.7 with the 2.2 and 2.7 in parallel, and that connected in series, all that with the 5-volt battery. Use the rules that we calculated for resistors in parallel or series of combinations I talked about in chapter 19. So then what I will do now is then calculate R. Then what I'm going to do is then after that, I will go through the second one set where we have a 1K hooked up with a 2.2, a 1K, 4.7K, and a 5.7K. Have you calculate that. Then I'll measure it, and based on that, you'll get a percent error for that. And then from there, we'll do calculate the voltage, the current, based on V over R. And for this case, I'll have you calculate what V over R, the current should be based on replacing each one of these sets with an overall resistance R. All right, so again, go back over to chapter 19 lecture to do that. And then the current will be V over R, where this will be 5 volts over whatever R is for that. And we'll just calculate that, and we're not going to measure it. So, but for the first one, we'll calculate R and then measure it, right? So, all right, I've now set up the first circuit, again, using this circuit. And what I've done is hooked it up on this breadboard with the 4.7K in parallel with the 2.2 and 2.7, and then that connected to that. So what I'm gonna do is find the overall resistance, and I use this ohm meter, and what I do is hook up the overall. Now again, you should have calculated it already. And this is what I get for the result of that, right? I get 6.81 kiloohms is the overall resistance for that circuit. Once we have that, we can now calculate the current based on the voltage over that overall resistance. All right. All right, now we're going to do the second one, combination. And this is the one, the bottom of page 1, with the 1K hooked into the 1K and the 4.7K in series, which then is connected in parallel with the 2.2K, and the result is connected in series with the 2.7K. So the first thing you'll do is calculate, if you haven't already, make sure you calculate R. And then what I've done here is set this up. I have the 1K, and then I have the 2.2K going by itself across, and then the 1 and the 4.7, and then that's connected up to the 2.7K. So now what I'm going to do is measure the resistance over all of this, and I'll have my ohm meter here. Now again, I'm not going to get exactly the same result as the calculated, but it should be fairly close. All right, and for this case, I get 5.25. And then from there, you can compare that to the value you actually got. Then calculate what the current should be. Again, we're doing the calculated one. Use the calculated current with 5 volts and connect it to the overall, replacing this circuit with an overall resistance that we talked about earlier. So that is the first part of Lab 5. Okay, now what we're going to do is measure the resistance of what we call a thermistor. Here's an example of a thermistor. It's a very accurate measurement device for measuring temperature based on resistance. It's how most electronic thermometers are made. And what we're going to do is measure, we have a heat temperature on, and we're going to measure the resistance at every 10 degrees and record the resistance for each one. So what we're going to do is get this right. When we get to 10, we'll stir this. When we get to 10, all right. So what we're going to do is take the temperature, right? So as we heat this up, and we'll record the resistance at every 10 degrees. And record the resistance at each one of those. Let's see here. Make sure we get it. Okay, we get this a little more accurately. We get 10 degrees, you get 1.985 kiloohms. So 1.985. So now we're going to go up to 20. We're not worried about the time. faster. Okay. Right, 1.810. 1.810. For 20 degrees. Climb a little faster. You'll let this go up. 1.660. 1.660. Okay. All right, now we're going to let it go up to 40 degrees. I think now it seems to be stirring pretty well on its own. Okay, here we go. Okay, 1.520. 1.520 for 40 degrees. 1.520. I'm just going to let it sit there now. We'll get the temperature as it goes up, as we get it pretty close to it. Yeah. I'm just going to leave it sitting there now. It getting it almost to 50. All right, and at 50, 1.425. 1.425. $55 degrees. Okay, and at 60, 1.348, 1.349, 1.349. Okay, two more, 70 and then 80. start getting close to 70. Okay. All right. $1.273. 1.273. And then you got one more to go. Okay. As we get near 80, our final temperature. All right, 1.239, 1.239, I would say. Oops, let me see. Yep. 1.239. That's our final temperature then. All right, I'm just adding here, as we can see, past 80 degrees, the temperature starts to rise again. And I'll show you a graph how this works. So this thermometer is reliable for temperatures generally between 0 and about 90 degrees. And above that, it actually starts to rise again. So I'm going to leave it because right now, as we get near the boiling point, you see we're now back up to almost 1.3, 1.3, 1.30 at 96.7, which is about 97. It's 1.3. See if we can get up to 98. At 98 degrees, we're up to 3 point. Okay, now water is starting to boil. 98, 1.320. 1.320. So that's our final temperature then. We're going to do. All right, here's a graph versus resistance versus temperature of the measured characteristics for this resist. The one is the dash line, the one on the top. Notice that at approximately, probably about 90 degrees, the resistance starts to rise again. This is a classic response for a thermistor. This is a logarithmic scale. Notice the scale goes in factors of 10, so it's 100, 1,000, 10,000, and so on. So it starts at about 2,000 at freezing point, drops, and then rises again. So I have a couple questions related to this on the lab.